Okay, this is day 2 of Identities, Honors Algebra 2. No. They told me to say it's timer time. All right, transform one side of an equation. When you are verifying identities, you can only work one side. Super important. You may not rewrite the other side. You want to use the basic trig identities along with the definitions of the trig functions to verify trigonometric identities. It's often easier to begin with the more complicated side. That's like almost always the case. And transform that expression into the form of the simpler side. You can only change one side. So if you decide to manipulate both sides, you will get no credit for your identity. It's not an identity anymore. All right, you must leave the other side like it started. Now here are some guidelines for proving identities. Thank you. It is usually best to work on the more complicated side first. Look for trigonometric substitutions involving the basic identities and may help simplify things. Third step, look for algebraic operations such as adding fractions. So if you see two things that are added or subtracted, you want to get a common denominator, etc. Factoring may come into play. If you see things that are squared or whatever, we'll look for things that may simplify the side you're working on and at least lead to an expression that's going to be easier to simplify for you. If you can't think of anything else to do, change everything to sines and cosines, and you do that quite a bit, right? Try multiplying both the numerator and denominator by the same trig expression. You might want to multiply by conjugates or something. Always keep an eye on the side you're not working on to be sure you're working toward it. And don't be afraid to stop and start over if you're not getting anywhere. Okay, some of them are much easier than others. There are many things that you will write that you may think are redundant or a little bit overdone. You have to show the work. First thing I see is that the left side is more complicated than the right. So I'm going to work on this side. Okay, I will not touch the right side. I will just keep rewriting the same thing over and over. So what am I going to do for the left side? Well, I don't see anything to trade out. There's no squared terms or anything. So I'm going to rewrite in terms of sines and cosines. So I'm going to rewrite the cotangent as what I've memorized it to be, which is cosine theta over sine theta, because it's x over y. Secant theta is 1 over the cosine, and that equals, now we got negative cosine theta on the right, and that's going to stay that way. Well, I figure I better get rid of this compound fraction here. I got a fraction, a term divided by a fraction. So I'm going to change it to multiply by the yeah, there you go, refliprical. So I'm going to flip over the cosine sine, sine over cosine. Okay. So this is where I'm at right now. If I multiply the sine times the sine over the cosine, I get sine squared over cosine. So I got sine squared theta. They both are going to have the same denominator, so let's go ahead and add the fractions or combine the fractions. It's subtraction. It'll be sine squared minus 1 on top, and then the denominators are cosine theta. Okay, there is something that I wanted to change or fix in your notes from yesterday. I failed to write this over correctly yesterday in one particular little spot. Thank you. Do you recognize this as anything? Okay, let me give you a little reminder. Sine squared theta plus cosine squared theta from yesterday equals 1. So the cosine squared of theta is 1 minus sine squared theta. That's the manipulation of it. But that's not what I have here. I have 1 minus sine squared here. This says sine squared minus 1. They're opposites, aren't they? Couldn't I rewrite that like that? So if I want to replace this sine squared minus 1, what do I have to replace it with? Not a positive cosine squared, but a negative cosine squared. Well, that's convenient, considering the right side's negative cosine theta. There's where we're going to get the negative sign from. Okay, did I lose anybody just there for a minute? If we don't get that, I want to explain it again. Okay. Oh, well, we started looking at, yeah, the identity sine squared theta plus cosine squared theta equals 1. All I did was subtract the sine squared. We've used this idea before where they were complete opposites and we would replace something with a negative 1 or the negative something. So all I'm saying is this and this is equal to that one. Negative 1 plus sine squared is this, okay? 1 minus sine squared, I factored out a 1, and that would be equal to the negative cosine squared. Yeah, you weren't here yesterday, so you're going to need to watch that one. All right, so I'm basically done here. The last step, though, which may seem like, oh, why do I have to write this? You do. The last step is to show that, you know, one of these canceled, and that that's equal to negative cosine theta. So you have to show that you realize this simplifies to the left and right side matching. Right? That's the end of the identity. We have verified that the left was equivalent to the right. Okay. On B, looks like the left side again is the complicated side. I don't know what the heck I'd do on with the secant theta over there. So I'm just going to work on this left side. All right. I don't see any squared stuff, so I'm not going to be using Pythagoreans yet on any of those identities. So I'm going to go start trading sines and cosines. The tangent is the sine theta over the cosine theta. Got to get that memorized if you haven't already. The cosecant is 1 over the sine. Okay, so right now I'm here. Before I think about even adding things, I'm going to get this simplified, this compound fraction. Fraction divided by a fraction. Let's show that that's equal to multiply by the reciprocal of the bottom fraction, which will be sine theta over 1. See? Okay, now when I multiply this, I'm going to get the sine squared theta over cosine theta plus, now guys, I'm going to think of this one as cosine theta over 1. I'll need a common denominator, and the common denominator is going to be cosine theta. I'll have to multiply top and bottom by the cosine of theta, so this is going to be cosine squared on top. The denominators are alike, so now I'm going to add the numerators. So I'm going to have sine squared theta plus cosine squared theta on top. Okay, I kept the right side the same the whole way down. And what can I do now? What's this equal? Sine squared plus cosine squared equals 1. So I have 1 over the cosine theta equals the secant of theta. And the last step is to write secant theta equals secant theta. Okay. Did anybody still need that before I go to the next problem? No? Okay. Verify that each equation is an identity. We've got the left side and the right side. The right side looks pretty simple. I'm going to work on the left. All right, so I'm going to, let's see, trade. Let's write in terms of sines and cosines. Cosecant squared would be 1 over the sine squared. But then we're multiplying that times cosine squared theta. Okay, if I multiply these two, I get 1 plus cosine squared theta over sine squared theta. What's cosine squared over sine squared? Yeah, that'd be 1 plus cotangent squared theta. And that's one of our identities from the manipulation of the Pythagorean identity. 1 plus cotangent squared equals cosecant squared, doesn't it? Isn't that in our identity bank? So what you would show is that this side, left side, is cosecant squared theta. So left side equals right side. Number 2, this is 1 over the sine. I'm going to work on, wait a minute. I don't know about that. No, I think I'm not going to work the left. Good luck. It's your game. Okay, we're going to add these. I think I should add, because this doesn't look like I'm going to have much to do with, because that's 1 over the sine, 1 over the cosine. So I'm going to work on adding these. So I'm going to rewrite the right side. That's cosine theta over sine theta plus sine theta over cosine theta. Now, they don't have the same denominator, so we need to get common denominator. I'm going to show what I'm doing. So I'm going to take that first fraction, and I'm going to have to multiply it by cosine, top and bottom. Take the second fraction, and I'll have to multiply it, top and bottom, by, kind of wrote crowded here, by the sine. I just wanted to make sure everybody knew what I was doing to get where I was going. Should have written the left side a little smaller. Okay, so my left side is still what it was. I'm going to write it tinier. And on the right, I got cosine times cosine on the top, which is cosine squared theta. Whoopsie. I almost wrote cosecant. Did you forget something? Oh. Told it. Oh, JV? Okay. All right, well, sorry to hear that. The bottom, guys, this is the common denominator. Sine, cosine. Plus, I'm adding the fractions. Sine times sine is sine squared. Okay. Somebody see something we should do now? The top equals 1. Okay, and then I can show that I know I can use the properties of fractions and separate one fraction times the other fraction like this. That would be equivalent to this. That's cosecant, and that's secant. And if this doesn't look at all familiar, as far as recognizing this as the cosecant, not the secant, you got some memorizing to do. So that's how you would end that one. Okay, I'll pause here till everybody has a chance to get that down. Anybody still need it? I'm ready to move to the next one. I know Colin just came back. Okay, ready? Ooh, I went too far. Like double too far. Left side for sure on this one. What can I replace? Uh-oh, wait, 1 minus sine squared. Is that something we know? This is a fast one. All right, cosine squared theta over cosine theta. This is a two-stepper. Just show me that you know you cancel out the bottom cosine with one of the top, and then you can say cosine theta equals cosine theta. Yeah. Well, 1 minus sine squared. I see it again. But I think I better change that tangent to sinings and cosines. I'm going to work the left. I'm going to change the tangent to sine theta over cosine theta, an equivalent form. And what should I do with that 1 minus sine squared? Replace it with, yeah, cosine squared. Another quick one. Because I can cancel that cosine with one of these. And there I go. Sine theta cosine theta equals sine theta cosine theta. Do you have to do this? Yes. Yes. That's the whole point, is that you're getting the left make equal the right. So you have to show you know you are there. You see what I'm saying? It's like, it's proof. So if you remember, I know some of you didn't really like proofs too much in geometry class. We just did a proof. We're doing proofs. It's just a little different. It's not a statement reason thing. And I know some of you probably liked proofs, okay. Pardon? No, they're not. They're not really as bad as you think, but I don't know. Anyway, this is a form of proof. So we're going to prove that the left side equals the right side. This left side's clearly more complicated than the right side. But that's, yeah, I don't know what the heck I'd do with that anyway. So we got to mess with this side. All right, they have non-common denominators, and it's added. So we need a factor? A factor. Okay. I'll tell you what, we need a common denominator here, guys. And it would be this times this. Denominator times denominator. So I'm going to have to multiply the first one. I'm going to rewrite the first fraction, cosine t, over 1 plus sine t. And I may be missing what you were trying to say just now, but this is what we're going to do. We're going to multiply the first one by 1 minus sine t, top and bottom. And we're going to multiply the second fraction, which I just rewrote, times the first fraction's denominator, 1 plus sine t. That's our first step. Now, we're going to simplify this. So the denominators are going to match. I'm going to write one fraction bar. What would the distribution be for the first fraction's numerator? Cosine t times 1 is going to be cosine of t minus cosine t times sine t. Plus, yes, it's the same thing. Theta is just a Greek variable. T is just the angle measure, or whatever the angle is. And then cosine t times 1 cosine t plus cosine t sine t. Lovely. That's the numerator of the new fraction that has a denominator of 1 plus sine t times 1 minus sine t. Or vice versa, I don't care which order you wrote it. All right, now I want to do some simplifying. I have a cosine t plus another cosine t. So how many do I have? 2 of them. I have a negative cosine t sine t and a positive cosine t sine t, so those cancel out. It's looking a little bit better than you thought now, I hope. What's the denominator going to be if you were to FOIL that out? 1 minus sine squared t. Now, I need to remind myself, because I kind of didn't want to clog up this whole paper. I still have equals over here. And what does it equal that we're heading towards is 2 secant t. So now that I have some room, I'm going to rewrite that, because technically I should have been writing it every time. I got to keep my eye on the prize, right? We're trying to get this to be the left side to equal the right side. What can I do now on the left side with the denominator? You need to get that memorized. Doesn't this equal something? Yep, so we've got 2 cosine t over cosine squared t. You can replace 1 minus sine squared t with a cosine t. And now just show me that you know you can cancel out 1 on the top with 1 on the bottom. Okay, so what I've replaced the 1 on the top with is a 1. So I have 2 times 1 over the cosine of t. Two times 1 over the cosine of t equals, well, 1 over cosine of t is the secant of t, so I'm done. 2 secant t equals 2 secant t. Amazing how that gets down to that, right? Not amazing, but it's algebra. Does anybody still need this? Wait a moment. I need to? No? Okay. 2 more examples, I believe. Is that correct? Or 3? Oh, somehow I jumped over and forgot about number 6 over here. Oh, boy. And I had somebody last hour say, what would you do when you see this? And they said, skip it. Well, that's not going to help you. So here, what we really want to do is think of something that we've learned from previous knowledge that we might be able to apply. And that's, here's a hint. I'm going to replace the tangent with an x and just write this as x to the 4th plus 2x squared plus 1. And now tell me what you see. Something that's, I hope, factorable, right? Doesn't that factor to x squared plus 1 quantity squared? That's a perfect square trinomial. This is a perfect square trinomial. So we can factor it as tangent squared theta plus 1 quantity squared. So this is going to be so much easier than you thought at first. Skip it. You know, not a good option. Okay, what is tangent squared plus 1 equal to? Secant squared. So you've got secant squared squared. And 2 times 2 is 4, so we got secant theta to the 4th power, actually, equals secant theta to the 4th power. It was a short one. Takes little pics. Okay, I know this is more fun than you wanted to have, the 7th period on a Wednesday. Here we go. Left side of this one. Ooh, definitely the left side. Don't know what I'd do over there, nothing. Well, what do you think you need? It's an addition. Common denominator, yes. Okay, so I'm going to need to multiply the first fraction by the denominator of the second and vice versa. So I'm going to rewrite the fraction, and I'm going to put parentheses around my denominator. And I'm going to multiply it top and bottom by the sine of x. Don't distribute. I'm giving you a little hint. The second fraction, I'm going to rewrite. And I'm going to multiply it by the denominator of the first one. 1 plus the cosine of x, top and bottom. Okay, for this moment, I'm not going to write my 2 cosecant, just give me some room over here. All right. Do not distribute the denominator. Leave it factored. So I'm going to write 1 plus cosine x, parentheses around it, times the sine of x for my denominator. Okay. My new numerator, sine times sine would be sine squared, plus, I have 1 plus the cosine times 1 plus the cosine. I am going to multiply that out. 1 times 1, 1 times cosine, another 1 times cosine would be plus 2 cosine x. And then cosine times cosine would be plus cosine squared x. Little reminder where I'm headed towards is 2 cosecant x. And geez, that looks awful big to be getting to that. All right, anybody see anything in my numerator? Okay, I heard you guys. Sine squared plus cosine squared is 1. So I've got 1 plus 1 plus 2 cosine x. And on the bottom, I just have 1 plus cosine x times sine x. Okay, well, what's 1 plus 1? All right, so let's go ahead and replace that with a 2. So I've got 2 plus 2 cosine x. Think about your goal. Cosecant 1 over the sine. Two plus 2 cosine x. I could factor out a 2. Okay. 2 times 2. Okay, 2 divided by 2 is 1, so I have to 1 plus 2 cosine x divided by 2b cosine x. That was funny. You couldn't hear that, but a revelation came about. Someone realized what's coming. Why didn't I distribute that numerator? You see? Yeah. We get to cancel out the 1 plus cosine x. So I'm left here with 2 times 1 over the sine x. And I'm done. 2 cosecant, oopsie. 2 cosecant x equals 2 cosecant x. I need to come over here and try to do this one now. And I had someone say last hour, can't we just cross multiply? No! No, you can't. No, not allowed. You only can change one side. So I'm going to work the right. Okay, the reason I'm going to work the right is because I'm going to multiply by something that you've seen before. How do you remember multiplying by something that is kind of like this denominator, but it's not the same thing? That makes things happen. I'm trying to remind you of an old stuff. You remember when you had something like this in the denominator? What would you multiply by? Would you say, Jack? The conjugate, 1 plus the square root of 3. Let's multiply by, I'm just going to rewrite the left. I'm going to multiply the right side, top and bottom, by the conjugate of the denominator, which would be, multiply it by 1 plus the sine of t. Oops, I don't know what the heck happened there. Okay, and don't forget that we should be foiling this, okay, on the denominator. I'm going to kind of slide down here a little bit. 1 plus the sine of t over the cosine of t is my goal. So let's see, I'm going to think we should distribute. I don't think so. You see how I've got that there already, and somehow I'm going to get rid of this? See what I want to have? Don't distribute. Oh, I just wrote cotangent. Not a cot. All right, so I'm not going to distribute. I'm going to leave it factored. And then I'm going to FOIL out the denominator because I multiply by conjugates. When I multiply this out, the middle terms drop, and I get 1 minus sine squared. Well, that seems like something we've used before today. Yes, sir. 1 minus the sine squared is the cosine squared. You got to show this. You've replaced the 1 minus sine squared with a cosine squared. And then don't mind if you just cross out the one on top with the 2 so that you show you have 1 left on the denominator. And guess what? We're done. Because now 1 plus sine t over cosine t equals 1 plus sine of t over cosine of t. And that's the end. All right, your assignment is worksheet 37A, and then the book page 900. Oh, by the way, I have a